Hello everyone, today in this video we are going to talk about integral calculus or integration. So after this video you should be able to apply the formula of integration which we will be using in physics. In integration we add up small components to form a large system which function as one thing. In previous video we talked about the differentiation. So in differentiation we find the derivative of a function, but integration is just opposite. We find the function from its derivative. So out here you can see in differentiation we find f dash x, that is derivative of fx from the function fx, but in integration we'll find the function fx from its derivative, that is f dash x. So integration and differentiation are just opposite to each other. So let's understand the differentiation and integration from tap and tank picture. So out here you can see from the tap drops of water is going and it is being collected in this container. So out here you can see the tap represent the rate of flow of water, and we already know the rate of change means differentiation, and out here we are collecting small drops to get the big volume. So that is the integration, in which we collect small components to make the large system. And one main application of integration is to find the area under curve. So suppose this graph is the graph of function fx, and out here I have to find the area, and to find this kind of area we don't have formula. It is neither triangle nor circle, so we don't have formula, so we have to use integration. So integration, we add small part to get the larger picture. So out here I'm considering the small rectangles out here, and if I add these rectangles I'll get the approximate value of the area, but I'll not get the exact one because I'm leaving some space out here. In order to find the area correctly, I can decrease the width of these rectangles like this. So out here you can see the space that I've left in previous case is less out here, but still we'll find some error. In order to find the area correctly, I can decrease the width to a very small length like this. So out here I'm considering many rectangles of length which is equal to this line. So if you add the areas of all the rectangles, then you'll get this area. So out here I'll get the exact value of the area. So using integration I can find the area under curve. So there are two types of integration. One is indefinite integration and another is definite integration. In indefinite integration we'll find the area of whole function. So we don't have boundaries, so I have to find the area of whole curve, or I have to integrate without the limit. But when you put the limit, so out here you can see I'm finding the area starting from A to B. So this is called definite integral. So in this video we'll talk about the indefinite integrals. So these are the applications of integration. So you have already seen we can find the area under curve using the integration. So in physics we can use it to find distance, velocity and acceleration, and work done also, and kinetic energy. So these are all the applications of integration. We use plus for addition and ddx for differentiation, cross sign for multiplication. So we should have something for this integration also. So for integration we'll use this symbol followed by dx, and this symbol is the operator of integration. So if you write this symbol y dx, so it means integration of y with respect to dx. And if you write integration of ga dA, that means ga is the function and I'm integrating with respect to a. So this means integration of ga with respect to a. So now let's see some formulas of integration. So the first formula is integration of k dx is equal to kx plus c. So out here k is a constant and c is another constant. So when you integrate a constant, you will get kx plus c. So example, integration of 5 dx is equal to 5x plus c. So this c is called constant of integration. So we have to write this constant every time when we integrate a function. So now second formula, integration of 1 by dx is equal to, that is also integration of x to the power minus 1 is equal to log x plus c. So integration of 1 by x dx is log x plus c. Next formula, integration of x to the power n dx is x to the power n plus 1 by n plus 1. So you just need to write this n plus 1 in the numerator, and you have to add 1 to the power plus c. But n should not be minus 1, because for n is equal to minus 1 we have already got the value, that is log x plus c. So in this case n should not be minus 1. So now let's try one question. So integration of x to the power 4 dx is equal to, so I just need to add 1 to the power, that is 4 plus 1, and I have to divide this function with 4 plus 1 plus c is the constant of integration. So when you simplify this, you'll get x to the power 5 by 5. So if you know the formula properly, then you can directly write this one without writing this part. So integration of x to the power 4 dx is equal to x to the power 5 by divided by 4 plus 1, 5. Next formula, integration k into fx dx is equal to k fx dx. So if you have a constant inside, you can take it out. So example is out here. So integration of 5x to the power 4 dx. So we know the formula for integration of x to the power 4. So I can take 5 out and I can integrate this. So your answer will be 5 into, so for x to the power 4 you have to write x to the power 4 plus 1 divided by 4 plus 1 plus c. So your answer is x to the power 5 plus c. Now let's solve one more question. Integration of 2 plus x whole square dx. So first I'll square this term. So I'll get 4 plus 4x plus x square. Now I'll open this bracket and I will integrate them individually. So the integration of constant into dx is 4x plus c. So I'm writing c1 because I'll get two more constant from this term and this term. Now this 4 will come out, and integration of x to the power 1 is 4 into x to the power 1 plus 1 divided by 1 plus 1 plus c2. And integration of x square is x to the power 2 plus 1 divided by 2 plus 1 plus c3. So instead of c1, c2 and c3, I'll write one constant, that is c, and I'll simplify this. So I'll get 2 out here, 3 out here. So I can divide this 4 by this 2. So I'll get 4x plus 2x square plus x cubed by 3 plus c. So this is the final answer. So similarly, let's solve this question. So first I'll simplify this root. So this is thrice root x square means x square power 1 by 3. Similarly, fourth root of x is x to the power 1 by 4. So now I'll simplify this further. So I'll multiply this 2 and I'll take this x to the numerator and it will become minus 1 by 4. Now I'll open the bracket and I'll integrate them individually. So now this 5 is constant, it will come out of the integration. So now this is integration of x to the power 2 by 3 is x to the power 2 by 3 plus 1 divided by 2 by 3 plus 1 plus 5 into integration of this part is x to the power minus 1 by 4 plus 1 divided by minus 1 by 4 plus 1 plus c. So I'm writing only one constant, because if I write c1 and c2 also, so I have to add it at the end. So I'm writing only one constant. So now next step, so I'll simplify this now. After this, I'll take this 3 and 4 into the numerator. So the final answer will look like this. And these are the other formulas for integration. Integration of e to the power x is e to the power x itself. Integration of sin x is minus cos x. Integration of cos x is sin x. And integration of sec square x is 10x. So this is the list of formula of integration and differentiation, and you can see how integration and differentiation are similar. Now in this formula, out here ddx of x is 1, and if you integrate 1 you will get x, and out here ddx of ax is a, and if you integrate a you will get ax, and ddx of x to the power 1 is n x to the power n plus 1. So out here the power is getting subtracted by 1, and out here the power is getting added by 1. So ddx of cos x is minus sin x, and integration of sin x is minus cos x. So all those formulas are also kind of similar. So now you can try these questions, and this is the end of the video. Don't forget to like the video and subscribe the channel.